Today I will talk about developmental change in curiosity, epistemic grazing, foraging, and farming. And I'm really thankful that Pierre-Yves was speaking this morning because I can basically jump into the experimental part right away. There is one thing that I want to talk about before anyways, which is this distinction between grazing, foraging, and farming, and what exactly do I mean by that? I think of these things as three different ways of acquiring information. And I would also say that as adults, we do all of them. So for example, it happens very often that we scroll on social media very mindlessly. And that is basically monitoring whether we like the information we are receiving, whether we want a different one, or whether we want to disengage from the information. But there isn't really a component of actively seeking the information. This comes in with the foraging aspect. So for example, if I'm doing a web search, is something where I am actively seeking an answer to a specific question, for example. And finally, there is this idea of farming, which is actually very, very similar to what Ude defined as autotelic exploration, where I can come up with my own goal, with my own plan, and then work towards it. So it would, for example, be something like a new experimental idea, and then I have to think about how I will implement the study, how I will collect the data, and this is really internally generated goal, and it can be quite complex. So I think that it's quite useful to ask at what point during development do we have these abilities? Because they might seem as ways of acquiring information on surface, but they're actually quite different from each other. So putting adults aside for a moment, I would rather focus on babies. And one thing that I think we can quite confidently say is that babies have this form of epistemic grazing. Any habituation study actually is a form of epistemic grazing, where infants are basically deciding whether or not to engage with a stimulus. We did a study where we were presenting stimuli in a certain sequence. Here, for example, this trefoil was appearing most of the times in the upper left corner, but sometimes it was appearing somewhere else. And so if we have these four locations, A, B, C, and D, we can track where exactly we were presenting the stimuli. And then the idea is we can measure the behavior of the infants, for example, with eye tracking, but we also want a very well-defined measure of learning progress or information gain, as Pierre was saying this morning. And one thing we can do a very simple model where if we start with the assumption that the stimulus appearing in any location is equally likely, we can then update these probabilities. So now, for example, we observe the stimulus in location A, and it becomes more likely, even more likely if we see it again. And we can really do this for every single trial. And then we can measure how much from one trial to the next this probability changes. And this is a measure of how much the new element is informative or is allowing us to progress in our learning. And if we do that, we can get a precise estimate of information for every single trial of our paradigm. And we were actually presenting multiple sequences, not just one. So we get many, many trials for each infant. And they were watching these sequences while we were recording their tracking data. These were 7, 8-month-old infants. And then what we measured was the looking time to the stimulus and the look away probability from the entire screen. So that at some point they would just completely disengage. And the idea here is, this is very similar to what I was saying about, for example, being on our phone. So we can look for a certain video for some amount of time. We can decide to just disengage from the phone altogether. And what we see here is that when the information was higher in the stimuli, and this is after controlling for other things like the passage of time, surprise, the uncertainty of the sequence, we can see that if there was more information, then the looking time to the stimuli was longer. And we can also see that if the information gain was lower, then the probability of looking away from the screen was higher. So I would say that this is a very basic form of acquiring information that I would define as grazing. However, if it shows that the infants can acquire information, it doesn't really tell us much about active foraging for information. And I think one problem here is that the world of the infant is quite complex. They still have a lot to learn about the world, but they're doing that, at least at the beginning of life, with a visual system that is quite poor. For example, it's much more blurred than our vision. They're less sensitive to things like colors, and also their oculomotor system is still to develop. So I was thinking, why don't we just, for a moment, get rid of all of these extra things that are complicating the picture, and we focus on the infant. Because in the end, there is something that the infants are exploring very, very early on, and that is their own body. So it's a specific kind of exploration that doesn't really require exploring the external environment in a way. And we actually have data where we were just recording the infants while they were lying on a bed with nothing else to interact with. So at some point, they start touching their own body in different areas with different amount of times, making different pauses of different lengths. And this is some very rich data. And so I started wondering, is this exploration data? So how can we tell that? One question we can ask is this exploration, is it not exploration? So to answer that, I will focus a bit more on what these states are. These are observations that are quite complex. They follow each other in time, and they are a combination of a location on the body, a duration, and also a pause between one and the other. So we have these very complex states, and what we really want to say, and this is what we can observe, and what we really want to say is there some sort of hidden state that we can't really observe that is either a more exploratory state or less exploratory state? So we want to basically understand whether there is a hidden state that is giving origin to this observable behavior. And we want to do that for every single behavior that we observe. The idea is also that, so for example, here we have S1 and S2 as two potential hidden states. And the idea is that we can also check whether, for example, once we are in state 1, it's just more likely to remain in this state 1. So for example, this is a high exploration state. And then at some point we switch to a lower exploration state. So actually what we just composed is a hidden Markov model, where if we fit the data to this model, we can sort of infer whether there are indeed two states, and then we can think of how are these states differing. So one thing that is often used to understand whether a state is exploratory or not is the entropy of the state. So if, for example, the state itself is more unpredictable, or better, the observable states that arise from the hidden state are less predictable, it's probably because the infant is doing something more novel or more diverse, more variable. So I thought of measuring entropy and see whether we can actually detect one state that is higher in entropy and one that is lower in entropy. So here I'm plotting the entropy values, and we recorded data from, for now we have 4 infants, but we have very many videos from these 4 infants. We have videos, multiple videos for each of these age groups, and they start from below 8 weeks of age up to more than 30, around 34. And what we see consistently across these age groups is that there is indeed a state that is higher in entropy and one that is lower in entropy. So one potential idea is, well, maybe there is a state where they are more exploratory and one where they are less exploratory. At the same time, I will call back baby Shakespeare to ask, is it actually foraging? So when I'm in this state that is more unpredictable, am I actually getting any information out of it? So I was thinking, what can we define as information here? One thing is that maybe infants are doing is they're mapping their own body. By touching different parts one after the other, they are mapping between different body areas. So when they're touching their own body, there might be some movements from one area to the other that are more unexpected, that are novel. So they carry more information. So what I did was actually something very similar to my first study, where I was measuring information in the external stimuli, but now I was measuring the information in the areas of the body that were touched. So some were more likely, some were less likely to be touched. So I didn't just have, for every moment in time, what hidden state they were in. Was it a high entropy hidden state, so it would have a value of 1 here, or a low entropy hidden state, value of 0. But I also had moment-by-moment measures of the information gain associated with each touch. So what I can do next, I can see whether the high entropy state is actually leading to gathering more of this information. And what we observed is that, indeed, and very interestingly, only up to about 24 weeks of age, there is a difference between the two conditions, where there is some state in which the infants are in that is harder to predict, is high in entropy, and that state consistently is leading to more information. So I would say that this is a form of epistemic foraging. It doesn't really involve exploring the external world, but it's foraging nonetheless. And up until now, I was talking about babies. But of course, with development, they develop more and more complex abilities. We also did other studies where we were trying to understand whether toddlers, in this case 18 to 36 months of age, were strategic in the way they were looking for information. And this is to say, not just this tendency to explore, but also many other abilities that are emerging in the months that follow make this ability to explore much more advanced. I will not get into the details of the study. It was actually recently published, so if you're interested, please check this out. The last thing, actually, that I want to do is I want to talk about epistemic farming or autotelic exploration. I feel like they're really synonyms. We are still working on this data, but I think it's quite interesting, so I'll give you a couple of examples. We had these three toys, and these toys could elicit some effects if you understood how to operate them. So the children, and in this case there were 3 to 4 year olds, were instructed that they could play with the toys as much as they wanted, and no further instructions on how the toys would operate were given. And then they were interacting with the toys. This is one first example of a child that is exploring this toy on the right, which is a house that has 4 doors, and on each door, inside each door, there are 4 fruits. And by pressing on the fruits, they might or might not activate the, the effect. You'll understand in a moment. So yeah, he's pressing different buttons, and then at some point, he presses one that activates the bigger light, and he's quite happy about that. So this is a successful use of the toy, or successful exploration. He was trying until he succeeded, and he really realized that was a success. And now I want you to compare this with this other infant. This infant is trying to open the doors, hasn't really realized that, sorry, child, I work too much with infants. This child hasn't really realized that he can press the buttons, but at some point he starts to eat all of the fruits, one by one. So again, this is autotelic exploration, or farming, in the sense that he is setting his own goal, and then he's carrying the goal out in a very systematic way. So when he's finished the fruits in one door, he goes to the other door, and then at some point he goes to the third door. So he's really like setting up a goal and carrying this exploration or activity out as long as it's finished. We're in the process of analyzing these data. My idea is that they are able to flexibly switch between different kinds of ways of acquiring information. So, for example, they can switch, in this case, from foraging, and I would say the first aspect is a type of foraging, to farming. And I also think there is some systematicity in that. For example, this kid on the right, that now has completed the activity and left, was really struggling with the task. So maybe in a moment where they see that their learning is not proceeding, they come up with a different idea, with a different activity that can actually keep them engaged. I just want to conclude by saying that I moved to the University of Cambridge, and here I still follow my passion for computational models. We are trying to build computational models that perform tasks as children do, but at the same time, their substrate is brain-like. So it looks like a brain, not just in a picture, but in the organization of the model, but it can perform tasks. So this is what I'll be working on in the next couple of years. With that, I want to thank all my collaborators, my supervisors, Sabine and Rohir, especially Azzurra, who is here, where we really had fun working on the project, on the Torchlight project that I briefly mentioned. And also, I've seen so many posters in the past day, very interesting posters from her group, many more today, so I really advise you to go and check them out. And my current advisor that funded my trip here, so thanks so much, Duncan Astle. And with that, I'll conclude. I just want to say we have launched actually last year at BCCCD DevStart, which is a platform where we're trying to report ways of collecting data, analyzing data for developmental science. So if you're interested in this, please go check it out. And with that, I am done. Thank you very much.
Okay, thank you, Francesco. Any questions?
Thank you, Francesco, for the beautiful talk. So, going back to the distinction between grazing, foraging, and farming, do you see them as, let's say, developing in complexity? Would you say that they build upon each other? Would you expect that first we see grazing emerging and then the following ones? And how would that differ from what we do in adulthood, where instead, as you said, all of them are present at the same time? How do they interact in adulthood? Maybe you are less familiar with that, but back me to the first aspect of my question. How do you see them? Also, in connection to the idea of, is there a goal or is there not a goal? Thank you.
Thanks so much. That's a great question. So the main reason I wanted to present these three things, grazing, foraging, and farming, is to say, I think it's good to keep them somehow separate. We shouldn't just conflate everything like exploration. There are actually very different kinds. And then once we are aware of that, we can start to think, is there some developmental change in these? I think it's too early to tell. One thing that also relates back to this morning with the conversation, with Q&A with Pierre-Yves, is about goals. I really think that is something that emerges later. We can also see it, for example, in our torchlight task, where the children had to explore, but they had basically a goal that was to find this hidden animal. And the task is not, they're really good at the task after 2 years of age. So I think that there is some ability to set up a goal and also to keep the goal in mind, pursue the goal that develops later on. I am not sure about the difference between grazing and foraging in terms of emergence. I was actually expecting, for example, in my study about self-touch, that we would see this emergence. Maybe we have to go even earlier. It was already a couple of weeks of life. Maybe it has emerged there. Maybe it's there from the start. That would be very interesting to see.
Hi. It's striking to see, with your example of epistemic farming, it's striking that you are also, same as Pierre this morning, using an example from a situation where we have, we were, as experimenters, we were hoping there was a kind of external goal, and then the children, infants, start to impose their own internal goals. And I guess I was wondering whether, there's a much more blurry line really between those things, that when we are giving a kid an external task, really the way that they're often probably solving it is, there's a lot of imputation they have to do to imagine what it is you actually want from this situation, and they're making up kind of their own kind of things, and sometimes they match with your goal and sometimes they don't. So I was kind of wondering whether when we designing external tasks, whether we should be thinking much more, using this as a sort of evaluative framework for how well we've got it right and how much the infants are bringing in their own intrinsic goals as a way of sort of helping us design better tasks. Makes any sense?
Yeah, that's a great point. I fully agree. And again, this was indeed not expected. And this is something that we observe quite a few times, though. At least one or twice during the session, I would say 50% of the children does something like this. I think that one thing that we really need to do at this point, where we are making paradigms that are more and more free, where they can do more and more things, which also means we have to give up more of the control that we have over the task. So I think one thing that we have to do in this situation is define clearly what is an internally generated goal and what is not. One thing that I think, for example, is useful in regard to this house is that they know that the house can generate an effect. They're not instructed about that. They're not told they have to generate it. They're not instructed about how to generate it. But I think they're also that the second child was fairly confident that eating the fruits wasn't going to generate the effect. So I think there is a switch from a moment where the child was trying to handle the door and trying to see whether he could do something with it. There is a switch, and maybe neuroimaging would actually be very useful in this case, where they actually decide to go for exploration instead of, like broader exploration instead of local exploration.
Okay, great. That's it for questions. Thank you so much.
Thank you.